Now let's go ahead and solve and graph some absolute value inequalities. Okay, so now we got the directions all set. Those are some linear inequalities. Now let's go ahead and do the solve and graph absolute value inequalities. Okay, so again, just like we did in for the equations, we got to create that compound inequality. Um, I'm sorry about that. Just like we did for the linear equations, we have to create the two cases, right? The positive and the negative version. But it's really important when we are creating these two cases, what we're doing is we're creating what we call a compound inequality, just like we did before, which is going to be our an or an and in compound inequality. So whenever you have a greater than symbol, you're going to be creating what we call a or compound inequality. And whenever you're creating a less than symbol, which we have down here, you're going to be creating a and inequality. And again, what's the difference? And you're looking for the intersection. When you're dealing with an or, you're just including both of them. All right. So it's when both solutions are going to be true. Oh, I'm sorry. It's including both solutions, not looking for the intersection. So let me show you. Let's go ahead and go through this again, how this works. So we have a 3y plus 4 is greater than 2. Or, right, so we have that. Or you could say a 3y plus 4 is less than a negative 2. So notice how I made this a negative, right? But then also I flipped the sign, right? Because basically you can think of like that negation as changing the sign here of your inequality. Like for an equation, it didn't really matter. But when you're dealing with an inequality, you can kind of think about like that as like multiplying that by like a negative, negative on that right-hand side. So therefore you're going to change the inequality. Now there's a couple different ways to look at this, but for simplicity, we'll just keep it this way. So let's go and subtract a 4 here. So a 3y is equal to a negative 2, divide by 3, divide by 3. Why am I putting an equation here? 3y, so that's going to be that's greater than, so a y is going to be greater than a negative 2/3. And then over here, we can subtract a 4, subtract a 4. So we have a 3y is less than a negative 6, divide by 3, divide by 3. Y is going to be less than a negative 2. Okay, cool. So let's go ahead and graph this. So a negative 2/3, think about a negative 2/3, like that is going to be like, here's negative 1, right? And let's say here's 0, and here's a negative 2. No, I didn't change that. Yeah. Okay. So we have a y is less than negative 2. So that's going to be going this way. And then y is greater than negative 2/3, which is going to be like, 0.66666 or something like that. So we'll go from there would be the graph. Now this one is greater than or equal to, but again, it's still an or, right? Now, before we do my two cases though, main thing I want to do here is multiply by 3 on both sides. Why am I multiplying by 3 on both sides? Because that's the reciprocal of 1/3, right? You could also divide by 1/3, but dividing by 1/3 is the same thing as multiplying by 1/3. So therefore, I have my two cases here as an 8, not like that. So I have an 8q plus 5 is greater than a 20, greater than or equal to, a 21. Or I could say a 8q plus 5 is going to be less than or equal to a negative 21. All right, so let's go ahead and subtract here. So I have a negative 5. So therefore, what's a 16? So 8q is greater than or equal to a positive 16. Divide by 8, divide by 8. Q is greater than or equal to a 2. And then over here, I'll subtract a 5, subtract a 5. So I have an 8q is less than or equal to a negative 26. Divide by 8, divide by 8. Q is less than or equal to, now again, you can divide by 2 on top and bottom, right? So that'd be a negative 13 over a 4. Okay, so now let's go ahead and graph this again. So I have a Q is greater than 2. So let's say put a 2 here. Now and then Q is less than or equal to a negative 13 over 4. Negative 13 over 4, remember how many times is 4 going to 13? Well, there'd be 3, right? Because that's 12, and then it'd be 1/4, right? So we could do like, I don't know, negative 3, negative 4. It'd be like 3 and 1/4, right? So negative 13 over 4 is the same thing as a 3 and 1/4. And again, you can always check your work. Remember how you can rewrite to mixed numbers to complex number, or mixed numbers to improper fractions? 4 times 3 is 12, plus 1 is 13, 13 over 4. So anyways, that's going to be like right there, and that's going to go in the opposite direction. All right, let's go ahead and do this last one. Now you can see this one is going to be a and, right? So again, first thing we do is want to go ahead and separate this. So I'll add a 3 to both sides. So I have a 5, absolute value of 3w plus 2 is less than a 10. Divide by 5, divide by 5. So I have a 3w plus 2 absolute value is going to be less than a 2. Okay, so now I can create my two cases, which is a 3w plus 2 is less than 2. And sometimes I like to write them in like caps so we remember. And a 3w plus 2 is going to be a greater than a negative 2. Okay, so now we just go ahead and solve these. And then remember, when we graph these, we're going to be looking for the intersection. So I subtract a 2 on both sides, and a 3w is going to be less than a 0. Divide by 3, divide by 3. W is less than 0. That one's good. And then over here, subtract a 2, subtract a 2. 3w is greater than a negative 4. Divide by 3, divide by 3. W, oops. Those 3's look really bad. Divide by 3. W is less than a negative 4 over 3. Okay, so now let's go ahead and graph this. So negative 4 over 3 is basically the same thing, right? Negative 4 over 3 is the same thing as a negative 3 1/3. Okay, so let's just, I don't know, let's put 0. Oh, let's put 0 here. And let's say put this as a negative 3, and then this would be like a negative 4. Okay, so if W is less than 0, that's going to be going this way. And if W is greater than or equal to a negative 4/3, that's going to be like going this way. So you can see like where they intersect, right, is between negative 4/3 and the 0. Right, now I'm going to leave this in here just so you guys can kind of see how I created it. But the final solution here is going to be from negative 4/3 to a 0.